Without grinding wheels, this machine shop couldn't function. Without grinding wheels to grind its turbines, this great ship would never have gone to sea. A grinding wheel was used to fashion this beautiful vase from solid glass and to grind your spectacle lenses. Without grinding wheels to grind its cylinders and crankshaft, this modern aircraft would have stayed on the ground. And even the machine used to join this film depends on grinding wheels to keep its blades sharp. The grinding wheel plays a most important part in the story of modern transport in all its forms. The many and ever-growing applications of grinding, from a pin to a battleship, have brought about vast and rapid developments in the manufacture of grinding wheels. And here you see the largest plant in Europe devoted to them, the great works of the Universal Grinding Wheel Company. The plant, which covers many acres, consists of a number of factories, each devoted to a different operation. From here, a great variety of grinding wheels are sent out to every quarter of the globe. It is early morning, and the workers are arriving in their hundreds. Let us make a tour and see for ourselves something of the work that goes on there. First, the raw materials. There are three main types of abrasive from which grinding wheels are made: bauxite, unirundum, and white bauxite. The latter, fused and prepared in this factory, is made from pure aluminium oxide. It's a highly friable abrasive, mainly used on hardened and special steels. The raw material is fused in electric furnaces in a temperature of well over 2,000 degrees centigrade. The giant carbon electrodes are lowered into a crucible containing the aluminium oxide. This process requires such enormous electrical power that a special plant has been constructed to develop the required current. Especially massive copper bus bars convey the current from the generator to the electrodes. Now the current is on and the fusing process begins. Once the electric arc is firmly established and a layer of alumina has fused, more material is added to the furnace and the process goes on for many hours. Each furnace is encased in a water-cooled jacket, and the contents are allowed to cool off after fusing before being removed. Then the furnace is wheeled out and the cover removed, exposing the mass of fused white bauxite, or pig as it is called. Weighing many tons, this solid mass is still too hot to be handled, and after a period for cooling has elapsed, it is broken up by pneumatic drills into lumps which can be conveniently placed in a crushing machine. In the crushing bay, the lumps of fused white bauxite are fed into jaw crushers, powerful machines which devour them with the greatest ease. Linked with these jaw crushers are rotary crushers, which produce a fine grain composed of various sized particles. The crushing is a highly important operation because the ultimate efficiency of the grinding wheel for its particular job depends largely on the shape of the particles of which it is composed. These particles should be polyhedral, that is to say, chunky and not flat or needle-shaped. On emerging from the crushing machines, the powdered abrasive passes over a series of powerful electromagnets which remove unwanted iron particles. The next process, which takes several hours, gets rid of any remaining iron particles or other foreign substances. The material is tipped into a cone. The wet mass now falls through the bottom of the cone onto a revolving table, which feeds it into a tubular dryer. Heated by gas burners, this machine converts the wet mass into dry abrasive grain of mixed sizes.